direct electricity here, so that is electrolysis. Okay, so you need to know some vocabs. So electrodes, you need to know what electrodes are. So these are points at which current enters and leaves the electrolyte. So what do you mean by electrolyte? Electrolyte is actually a solution, an aqueous solution, or a molten, let me say, a molten form of a compound that is able to conduct electricity. So I believe I'm going to talk about that there as well. So an electrolyte is the name for the substance being broken down. Yes, it is the one that we have inside the container. So you have the electrodes. There are two of them, which we are going to see as we progress in the presentation. So these are also vocabs. Remember, we mentioned that electrodes are points at which current enters and leaves the electrolyte. An electrolyte is the solution that conducts electricity, and it is the one that is broken down. So these electrodes that we're talking about are now divided into two. You have the anode and you have the cathode. There are two of them. Anode, those ones are the positive pole. So you see that these are electrons connected to the positive pole. The electrons leave just they leave through this electrode. So that is anode for you. They leave through this electrode. While for cathode, electrode connected to the negative pole of the cell. So take this as the negative pole and anode as the positive pole. So electrode connected to this electrons enter the electrolyte through this pole. Okay, so that is cathode. Now there are some ions uh, that you need to know as far as electrolysis is concerned. You need to know that when the solution of the electrolyte is broken down, it's split up into the various component ions that make it up. So those ions, you may have the positive ions and you may have the negative ions. So the positive ions, this is what you call it. You call it the cations. So these are positive ions which go to the negative electrode and then they accept ions there, or they accept electrons there rather. And anions, those are the negative ions which go to the positive electrode and give up electrons. So something like this, which we are going to have a better explanation as we progress forward. And now this is a picture of what the electrolytic setup is what it looks like. So this is electrolysis of molten NaCl, that is sodium chloride. Sodium chloride is NaCl. So you can see the setup. This is a container here. You can see that container. So you can see the electrodes inside. This is one electrode. This is another electrode. You can see this is the cathode and this is the anode. You can see the anode is the positively charged electrode and the cathode is the negatively charged electrode, which are connected to a battery, which is the source of electricity. The form of electricity you have from a battery is the DC, is a DC. So the setup is all of the DC circuit. So you see this positive pole connected to the positive pole of the battery, and you see this negative pole connected to the negative pole of the battery. So this sodium chloride, which is the electrolyte, as earlier mentioned, remember electrolyte is the solution that we pass the electricity into. So this is the electrolyte. So once the electricity is passed, you see it's what do I say now? It breaks down this NaCl into the component ions. Can you see? So Na plus, that's sodium. Sodium is Na plus, and then chloride minus. So you see the direction of the arrow. These chloride ions are more attracted towards the positive pole, and these sodium ions are more attracted towards the negative pole. If you do remember very well, principle of electrostatics, like charges repel, unlike charges attract. So these are unlike charges. They are going to attract each other. These are unlike charges. They are going to attract each other. Okay. So remember, always remember the setup of electrolysis. It is very easy to draw. You have this something like a container, something like a rectangular shape, but it's not having a head cover, and you have this small tiny rectangular something dipped into it, which are the electrodes, and then you have connected battery to it, positive to positive, negative to negative, and then you have the solution of the electrolyte already dissociated. Is that clear? So you can see, can we see hear me?